Hello students. Today I am going to discuss another most important problem, uh, that is electric field due to a curved wire in the form of an arc. This is a problem type theory. So this you can consider as the theory also. So যিকোনো আর্কৰ বা কাৰ্ড ৱায়াৰৰ যদি আৰ্কৰ ফৰ্মত থাকে চাৰ্জড ৱায়াৰ তাৰ আমি ইলেক্ট্ৰিক ফিল্ড আমি কেনেকৈ উলিয়াম at the center of that arc. Okay, so let me proceed. So we are having let me take one coordinate system, xy coordinate system. Okay, let me take one xy coordinate system here. So this is our y-axis, okay, and this will be our x-axis. One is our x-axis. Take this as y-axis, and we have a arc like this. Okay, this arc is nothing but the wire with the charge density lambda. Okay, this wire is having the charge density lambda. Okay, this wire is having the charge density lambda. Let me put it as the charge density. So charge density is lambda. So this procedure is very important. If jodi etu ami jano তেতিয়াহ'লে কি হ'ব, we can find the electric field for any curved wire of this system. Okay, so let the radius of this arc be r. Okay, the radius of this arc be r. Then we need to find out the electric field at point O, at the center of this. Because of this charge distribution, let it be positively charged. There is distribution, uniform charge distribution is there. So if this is lambda, then how to proceed this? We'll take one element. Okay, since this is continuous, so we'll take one element here at an angle theta from the x-axis. Okay, so of the element will have a theta of d theta. Okay, আমি d theta thickness এটা element লওঁ ইয়াতে, এই এলিমেন্টৰ কথা কৈছো মই. This is the element here. Okay, let me take this as the element, this particular element. So this element length will be your r d theta. Okay, r d theta. So first we need to find out, this is your element. Okay, this element, a small element here. Okay, this one is your element. So electric field because of this element, okay, this is the whole wire, this element will be your DE. Okay, now we know the electric field definition of the electric field. Mathematical E vector is equal to 1 by 4 pi epsilon naught. Okay, so here we can write Q divided by position vector of field point with respect to source point, that is Q, and this is the vector, position vector of field point with respect to source point. Okay, so RFS is the vector. What is this vector? This vector stands for position vector position vector of field point with respect to source. Okay, source means যোনটো সোর্সৰ কাৰণে আমি ইলেক্ট্ৰিক ফিল্ড দেখি আছো. So that source is this particular element. Okay, this particular element is the source here. So let me write the coordinate of this source. Now if you write the coordinate of this, you will get x coordinate as r cos theta, this much. Okay, and y coordinate will be this much, so this will be your r sin theta. So coordinate will be r cos theta and r sin theta, and in general this center point is having the coordinate 0 0. Okay, so this is your field point, this O is your field point. Field point means where you need to find out the field, electric field, because of the system, and the source now will be this particular element. Okay, element. So we'll write these two parameters. One is position vector of field point with respect to source. That means position vector of field with respect to the origin minus position vector of source. Okay, now what is the position vector of field point? We can write it as 0 I cap plus 0 j cap. Okay, now position vector of this source point, this is your source element, is the source here. Okay, so position vector of field point is your 0 I cap plus 0 j cap minus position vector of source point is your r cos theta I cap plus r sin theta j cap. Is it? Okay, overall we are having minus of r cos theta I cap minus r sin theta j cap. Is it? So this is your position vector of field point with respect to the source point. Now what is the magnitude of this vector? Is your root over r square cos square theta plus r square sin square theta. This will give you r. Okay, and it should be r. This is the distance between this field point and source point. This is r. Okay, now we will put these values here, and the charge of the source is, now charge of the source, this elemental source, charge of the elemental source is what? Here, charge of the elemental source is given by dq, that is equal to how much? Is your lambda into r d theta, right? Because length of this element is r d theta. Length of this element is r d theta, because this is the arc of thickness d theta, its radius r, so r into d theta is the length, and lambda is your nothing but the charge per unit length, right? Charge per unit length. Okay, so dq is written as lambda into r d theta, lambda into r d theta. Now we have the dq, this charge value, then rfs and rfs vector. Okay, so we will put these values here in the formula. Okay, if we put these formulas in the parameters in the formula, 1 by 4 pi epsilon naught, that is dq by position vector of field point with respect to source point q, position vector of field point with respect to source, this is the vector. Now we will put 1 by 1, so 1 by 4 pi epsilon naught dq is your lambda into r d theta, then this rfs vector we already have calculated, that is r, this r cube, rfs vector is your minus of r cos theta I cap minus of r sin theta j cap. Is it? So we will have two components of this electric field. That component is, one is dex component, another is dy component. Okay, now first we will calculate for dex component. Dex component is your lambda r d theta by 4 pi epsilon naught r cube, that is minus of r cos theta I cap. And at the same time, we have dE y component, that is your lambda r d theta divided by 4 pi epsilon naught r cube minus of r sine theta j cap. Okay, now we will calculate this lambda r. Here we can cancel out this one, r, this r will come out, so r square, so it will be lambda into d theta divided by 4 pi epsilon naught r square r to, in the denominator it will be r, in the numerator it will be only cos theta, minus sign will be here cos theta I cap. Okay, so we can rewrite this as minus of lambda by 4 pi epsilon naught r, these are constant, now cos theta into d theta. Okay, now here in this side, again similarly r, this r will got cancelled and there will be an r, so dEy component will be your minus of lambda 4 pi epsilon naught r into sine theta d theta. Okay, so this is your I cap and this is your j cap. Okay, now if we need the whole electric field, this is the electric field along x direction only because of that particular elemental source, and this is the electric field or field y component of the electric field only because of that elemental source. Okay, now we need to integrate if we need the electric field into the continuous system, that is the curved wire of surge density lambda. So let me integrate this, and we will get the total electric field along x direction. If we integrate this, minus sign will be here, lambda by 4 pi epsilon naught r, this is constant, integration of cos theta d theta. Okay, now here also ey, if we integrate it, minus of lambda by 4 pi epsilon naught integration of sine theta d theta. Okay, so we will get minus of lambda by 4 pi. Now it is from theta 1 to theta 2. We will have the range of theta. If we see in the diagram, okay, to see this theta will be from this one. First element will be here. This curved wire ranges from this point to this point A to point B. Point A is at an angle theta 1 from the x-axis and point B is at an angle theta 2. So range will be from theta 1 to theta 2. Okay, range will be from theta 1 to theta 2. So with this, if we put the values of theta 1 and theta 2 in my integration formula, we will get the value of x component of the electric field and y component of the electric field. Okay, so this will give you the cos theta d theta is your integration of cos theta is your sine theta. Okay, is your sine theta. So it is from theta 1 to theta 2, it will be negative. Okay, similarly ey is also minus of lambda by 4 pi epsilon naught. Okay, so integration of sine theta d theta is your minus of cos theta, this from theta 1 to theta 2. Okay, so this will give you the x component and y component of the electric field. Okay, so let me do it for some system, that means first if we do it for quarter of a circular arc, okay, if my wire is of this shape, okay, it is ranging from, and we need the electric field here, it is ranging from 0 to pi by 2, right? 0 to pi by 2, it is 90 degree. If we put it here, in this formula, particular formula, we will get Ex as, we will get the Ex as minus of lambda by 4 pi epsilon naught sine theta. Sine theta is from 0 to, theta 1 is will be equal to 0, and theta 2 will be equal to pi by 2. So if we do this, sine of pi by 2 minus of sine 0 degree, is it? So we will get it is minus of lambda by 4 pi epsilon naught sine pi by 2 is 0 1, okay, sine 0 degree is 0, so it will be this one, okay. So the value will be, Ex will be minus of lambda 4 pi epsilon naught r. So we can write it as minus of lambda by 4 pi epsilon naught r minus I cap, is it? That means overall electric field will be along this direction. X component of the electric field will be in the negative x direction, in the minus I cap direction, okay. Now for this we will have minus of lambda by 4 pi epsilon naught r. Cos theta is again, cos theta 1 will be 0 degree to 90 degree, okay. Now if we put these values, minus of cos of 90 degree minus of minus cos 0 degree, that is plus, that is cos of 0 degree, okay. So minus of lambda by 4 pi epsilon naught r minus cos 90 means it is 0, cos 0 is 1. So again we have got it as minus of lambda by 4 pi epsilon naught r, okay. We can write this as minus j cap, okay. This is y component of the velocity, y component of the electric field, okay, electric field. So we are left with x component will be along negative x direction, y component will be along negative y direction, okay, if it is like this. Now if we have the electric field, if we need to find out the electric field due to this, okay, if it is complete, then theta will be vary from, what? Theta will vary from, theta 1 will be equal to this one, okay, 0 degree, because theta 2 theta we have measured it from the positive direction of x-axis, and theta 2 is your it is 180 degree. We can say it is equal to pi, okay. So for this system, again it is positive, okay. For this system, electric field along x direction will be equal to how much? Minus of lambda by 4 pi epsilon naught r sine of, this is sine theta, so sine of theta 2 will be equal to sine of 180 degree minus of sine 0 degree. So sine 180 is 0, sine 0 0, so Ex will be equal to 0. Now overall electric field will be along y direction, that is Ey will be there, that is minus of lambda by 4 pi epsilon naught r. This will be your minus of cos of 180 degree minus plus of cos 0 degree, okay. So from this we will have the minus of lambda by 4 pi epsilon naught r. So minus of cos 180 means minus cos 180 is your minus 1, minus plus 1, this will 2, okay, this will be your 2. Minus of cos 180 is minus 1, again minus plus of cos 0 is 1 plus 1 2. So this will be your you can write it as 2 lambda by 4 pi epsilon naught r minus of j cap, okay. It will be along the negative y direction. So similarly, if you have this particular system like this, then you can find out the electric field. Let's try it yourself. And if you have the whole circular charged wire, then if you need to find out the electric field at the center, then it will come out to be 0, okay. So if you know the range of this theta for this particular card or wire in the form of an arc, then you can find out the electric field using this particular formulas and this particular procedure, okay. And if you know the procedure, then it is very easier to calculate the electric field at the center of the arc by using this particular method, okay. So I hope all of you have understood this problem. Now, again, if we write the net electric field at the center of this arc, then what we will have is, if we have this is your y-axis, this is your x-axis, then this is your y-axis, and this is our arc. Okay, this was our arc. This was our arc of this having charge density lambda here. So we took this particular element, making an angle d theta at an angle theta from the x-axis. So first element is here at A, and the last element is at this B. So first element is making an angle theta 1 from the x-axis, this is making an angle theta 2. So if theta 2 minus theta 1 is your phi, that means the angle subtended by the arc, this is the angle subtended by the arc at the center. Okay, at the center. So this is our field point, and if we write the net electric field at the O, we'll have E as Ex I cap plus Uy j cap in the vector form. Now Ex, we got it as, okay, Ex we got it as lambda by 4 pi epsilon naught r. So this one is your Ex. Okay, so this one is your Ex, and this one is your Uy. If we write this, we'll get it as, and write it as minus of lambda by 4 pi epsilon naught r. Here it is sine theta from theta 1 to theta 2, it is I cap, plus minus of lambda by 4 pi epsilon naught r, it is cos theta from theta 1 to theta 2, it is minus cos theta, right? So if we write this as 4 pi epsilon naught r, we will have it is sine theta 2 minus sine theta 1 minus I cap. At the same time, we can write it as lambda by 4 pi epsilon naught. This is the x component. Y component we can write it 4 pi epsilon naught r. It will be cos of theta 1 minus cos of theta 2 minus j cap, right? Minus j cap. Okay. So if we write the magnitude of this electric field, we will be having, okay, under root of this square plus this square, right, as the vector says. Okay, so lambda by 4 pi epsilon naught r square, this will be common for both of these, so we'll square this one, sine theta 2 minus sine theta 1 whole square plus cos of theta 1 minus cos of theta 2 whole square. Okay, so again, if we calculate this, we'll be left with lambda by 4 pi epsilon naught r whole square. This will be sine square theta 2 plus sine square theta 1 minus of 2 sine theta 1 into sine theta 2. Okay, again plus cos square theta 1 plus cos square theta 2 plus 2, sorry, it will be minus, right? It will be minus of 2 cos of theta 1 into cos of theta 2. So this will give us, what? This will give us if you see sine square theta 2 plus cos square theta 2, this will give you 1, and again sine square theta 1 plus cos square theta 1, this will also give you the 1. So it will be lambda by 4 pi epsilon naught r whole square. In the bracket we will have, this is 1 plus 1 2, 2 minus, taking 2 common, we will have sine theta 1 sine theta 2 plus cos theta 1 into cos theta 2. Now using the trigonometry we can have, this as the lambda by 4 pi epsilon naught r, lambda by 4 pi epsilon. You can take the lambda by 4 pi epsilon naught r as the k by r also. So taking 2 common from this, we will have 1 minus, this is from the trigonometry, this will be cos of theta 2 minus theta 1. Now as cos of theta 2 minus theta 1, I have already taken this as, this was like this, no, theta 1 from the x-axis, and the last element is theta 2. So the arc is making an angle of theta 2 minus theta 1, that is equal to phi, as I have already taken that. So from this we can write it as lambda by 4 pi epsilon naught r whole square, taking 2 common, this is your 2 sine, this will be your phi, no, cos theta 1 minus theta 2 is phi, to sine square theta 2 minus theta 1 by 2. Okay, because this can also be written as phi, right? Phi, for this theta 2 minus theta 1 is phi. So we will be left with, k by r all square. K means lambda by 4 pi epsilon naught, and this is your 2 into 2 sine square phi by 2. Is it? Phi is what? Phi is the angle subtended by the arc at its center. So from this k square by r, we will left with k by r. We have lambda here. K is your 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught. So lambda k by r into 2, from square root we will have the 2 and sine phi by 2. Okay, so electric field magnitude at the center of the arc is your 2 lambda k by r into sine phi by 2, where phi is the angle subtended by the arc at its center. Okay, so this is the magnitude for any arc. If you know the angle subtended by the arc at its center, then we can find out the magnitude of the electric field like this. If this angle is phi, then it will be always symmetric to this line. The line, it will be along the line which bisects this arc, okay, into it equal halves. Okay, so this will be the direction of the electric field for any arc. If it is positively charged, it will away from the arc at the center, and if it is negatively charged arc, then it will be towards the arc. Okay, so using this also we can have the, if we have a circular arc like this, because this is 90 degree, so angle will be phi will be equal to 90 degree, so this will be sine 45 degree phi by 2. For this, if we have this one, then phi will be equal to 180 degree. For this one, phi will be equal to 270 degree. This one, it will be 360 degree. Okay, now if it's 360 degree, then 360 degree by 2, it is 0, will be 0. So this is how we can find out the electric field at the center of any charged wire in the form of an arc at its center. Okay, so I hope all of you have understood this problem. Thank you.